Hey guys, we're going to get started in chapter 3. So let me present my screen and we'll get going. Okay. So in chapter 3, we're going to be talking about all different types of lines. Let me get to the top there. So we have some vocabulary to get us started. First, we have parallel lines. You can see the characteristics, the definition, the diagram, what you can say, and then how you can write it. All right, so parallel lines are lines that never intersect. They stay at the same distance apart. They're collinear and they have 0 points in common. All right, so here's two lines that are parallel. This little arrow here and here, that's what we draw on our lines to indicate that they're parallel. And we can say that line AB is parallel to line CD, or you could say line L is parallel to line J. So I know the letters here are super teeny, but A and B and C and D are points on the line, so you can name the line using any 2 points. Or this little, it's usually a lowercase cursive letter. In this case, it's not cursive, but this letter here, J, and this letter here, L, there's no dot next to it, so it's not a point on the line. It's a letter given to name the line. All right, and then the way you write it, you can write that line AB is parallel to line CD. Make sure you put your line symbol above the letters, and these two parallel lines, those two vertical lines, are the symbol for parallel. Or if you're naming it using that one single letter instead, you'd say line L is parallel to line J. So that's the notation. All right, intersecting lines. They pass through the same point. There is 1 point in common. That's called the point of intersection. So here you can see line HG, and here is line EF, and they intersect, they meet at this point I or L. Not sure exactly what letter that is, but so you can say line HG and line EF intersect at point L, or you can write it that line HG with the line symbol intersects line EF. There's no symbol for intersection, so you do have to write it out in words. All right, perpendicular. Perpendicular lines intersect, so they are considered intersecting lines, but they intersect in a very particular way where they form a right angle. Okay, so two lines that intersect and form a right angle are perpendicular lines. And you can write it, line LM is perpendicular to line JK, or using the notation, an upside down T is the symbol for perpendicular. So line LM is perpendicular to line JK. Coinciding lines are two lines that have every point in common, infinite points in common, because they overlap. Okay, so if you have a point NO, and a point, or a line, not a point, a line NO and a line OP, and they intersect at every single point, they overlap one another, we call them coinciding lines. There's no symbol, okay? And then skew lines. Skew lines are lines that are non-coplanar and they never intersect. They have no points in common. Okay, I'm going to go through an example of how to identify skew lines, but an example here would be TS, this line right here, and QR, this line back here. They are skew lines. And again, there's no symbol for skew, so you just have to write it out. Okay. So when two lines intersect, they form different angle pairs. Okay, so we're going to talk about some of those now. They form what we call corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles, or sometimes instead of consecutive interior angles, you're going to see it listed as, I'll write it here. Where am I? So these are the same as same side interior. All right, so depending on the textbook you pick up, the website you look at, the worksheet you're on, some books call them consecutive interior and other books call them same side interior. They're the same thing, okay? So Let me scroll back up, sorry. Okay, so two angles are corresponding when they have corresponding positions. For example, angle 2 and angle 6 are above the lines and to the right of the transversal. So let's talk for a second. These are my two lines, okay? They're not parallel, they're not, they're just two lines. They will eventually intersect if we were to extend them. And then this third line that intersects both of the lines, that's what we call the transversal. So you see the T there. So if you look at angle 2, okay, angle 2 is right. Oh, I gotta get my pen back, sorry. Angle 2 is this angle right here. And angle 6 is this angle right here. So angle 2 is above this line here, and angle 6 is also above this line here. And then if you think of the transversal having a right-hand side and a left-hand side, both the angles are to the right. Okay, so they're in corresponding positions. Next, we have what we call alternate interior angles. So you see angle 4 and angle 5 are both in the interior space. This space right here is what we refer to as the interior space, and then the exterior outside of those two lines. So these two angles are interior angles, and they're on opposite sides of the transversal. Okay, so they're alternate interior. Then we have, let me scroll down, alternate exterior angles. So just like we have interior space, we also have exterior space. This is the exterior space, and this is the exterior space. So both angles 1 and 8 are on the exterior, and they're on opposite sides of the transversal. Right angle 1 is to the left, and angle 8 is to the right. So those are alternate exterior. And finally, we have consecutive interior, or remember I also said they'll also be called same side interior. This is actually what I refer to them as. So that's the terminology you're going to hear me use, same side interior. All right, so they're interior angles, right? This is the interior space. So they're interior angles, and they're on the same side of the transversal. The transversal is the right-hand side and the left-hand side. They're both on the left-hand side. Okay, so we can classify angles based on their location in relation to those three lines that are drawn. All right, let me scroll down. Okay, so we have two different postulates we're just going to quickly read through. One is called the parallel postulate, which says if there is a line, so here's line L, and then a point, and a point not on a line, then there's exactly one line through the point parallel to the given line. So just to kind of illustrate this again, if I was to draw a similar diagram as I read through. So if I have a line, okay, we'll call this, there we go. We'll call this line L. And then I draw some point not on the line. We'll call this point M. There's only one line that I can draw through point M that would be parallel to line L. So this line here goes through point M and is parallel to goes through point M and is parallel to line L. So that's what that postulate tells us. All right, next we have the perpendicular postulate, which says something very, very similar. So I'll kind of draw a diagram as I'm going. And says if there is a line, so just draw any line on your paper, and then a point not on that line. So here's my point. This postulate tells us that there's exactly one line through that point that'll be perpendicular to the given line, right? I could draw a bunch of lines through that point. I could draw one going this way. I could draw one going this way. I could draw one going this way. There's lots of different options, but there's only going to be one way to draw a line that goes through this point and is perpendicular to the given line. And it would look like that, right? And to indicate it's perpendicular, put our little box. Okay, so that's what that theorem tells us. All right, so we're gonna actually only do examples 1 through 4 on this page and then jump to the next page for the rest of the examples. So I want to talk about skew lines here. It says in exercises 1 through 4, think of each segment in the diagram as part of a line, right? It would be crazy confusing if every single segment had arrows, if it extended and had arrows, it would just make the diagram look really messy. So we just have segments to look at here, but we're going to refer to them as lines. So here it says, keep reading the directions, which lines, line or lines, or plane or planes contain point B, that's important, make sure you're reading the directions carefully, contain point B and appear to fit the description. So we want line skew to line FG. So this is the given line that we're focusing on right here. Okay, so we want to find a line that goes through point B, this point right here, all right, and is skew. So oftentimes when I'm first explaining skew, I say to my students, find everything that's not skew. Find every line that is parallel to FG and intersecting to FG. So let's go through and trace them. This line is parallel to FG, EH is parallel to FG, and DC is parallel to FG. Now let's trace over all of the lines that intersect FG. So BG intersects at point G, AF intersects at point F, what is that back there? EF, yeah, EF intersects at point F, and then HG intersects at point G. Okay, so I've traced over all the lines that are intersecting and parallel. So everything else that's left over would be considered skew. So this line here, ED, is skew. Line ED. Right, this line right here, AD, is skew. This line here, BC, is skew. And finally, this line right here, CH, is skew. So again, to find skew, it's easiest, in my opinion, to find everything that's not skew, meaning find all of the lines that are parallel and intersecting, and whatever's left over is skew. Okay. The next one, a line, oh, by the way, I didn't read the directions carefully. I did, but then I didn't focus. So those are all the skew lines, but remember, they only want the one that contains point B. So which of these contains point B? That would be this one here. So that's actually the final answer. It would be BC. All right, but we'll just list them all for extra practice. All right, so let's list all of the lines that are perpendicular to FG, and then we'll answer the question. So again, FG is this line here. The ones that are perpendicular, okay, the ones that form a right angle, I see that BG, right, they intersect at point G and a right angle is formed. And then also AF intersects at point F and it is perpendicular. You see the right angle symbol. All right, I think that's it. So my two lines that are perpendicular would be AF, line AF, and line BG. But remember what the directions say. We want only the one that has point B, so that would be BJ. All right. Okay, the next one, we want to find a line parallel to FG. So again, here is FG. Highlight all the lines that are parallel. So that's EH, that's AB, and that's DC. So we can write them all down. We said EH, line EH, line AB, and line DC. Okay, but again, we only want the one that contains point B because that's what the directions tell us. So our final answer here would just be AB. All right. And then finally, there, we want a plane, planes parallel to FGH. So let's identify that plane first. Go from F to G to H. So I'm talking about this back plane right here. Now, again, our textbook often uses 3 letters because you need at least 3 non-collinear points to form a plane, but I like to close it off and think of it as a 4-sided figure. So which plane runs parallel to this back one here? It would be this front plane right here, which does include point B. All right, so we're talking about plane, and pick a point and either go clockwise or counterclockwise to name your plane. So I could call it like A, B, C, D, right? I could call it plane B, A, D, C, but don't crisscross when you're naming your planes. Don't go A, C, B, D, because that's not how you would trace it. Think about how you would trace it, okay? All right, so that is all the examples on that page that I want to do. Now I want to jump to the next page. Okay, so it says in the diagram below, line 3 is the transversal because it intersects the other two. Remember I explained that in the vocabulary? We have line 1 and line 2. Line 3 intersects both of them. So this line here is your transversal. So I'll write that in my pen. So this line is your transversal, right? It says which angles are inside the spaces of line 1 and line 2. So remember, this is your interior space. So which angles are on the interior? All right, let me scroll down so I can write my answers down. The interior angles would be angle 3, angle 4, angle 5, and angle 6. Next it says, which pairs of angles listed in number 1 are on the same side of the transversal? So I'm just focusing on these angles, not 7 and 8, those angles there, right, those 4 angles, and I want to know which ones are on the same side of the transversal. So here's my transversal. I'm looking to the right and then to the left to find the same angles that are on the same side. All right, so angle 3 and 6 are on the same side. So angles 3 and angle 6 are on the same side. And then the other pair would be angle 4 and angle 5. Well, by identifying those, you just identified, I gotta erase, it's not gonna move with me. You just identified the same side interior angles. So we'll look at those again. I'll write them down again. The same side interior angles are angles 4 and 5 because they're on the same side and they're both inside. And then angles 3 and 6 are same side interior. All right. Now it says, for the next one, which pair of angles listed in number 1 are on opposite sides of the transversal? Those are your alternate interior angles. So again, I want to look at the interior angles and which pair are on opposite sides of the transversal. So 4 and 6 are alternate interior and 3 and 5 are alternate interior. Okay, so your alternate interior angles would be angles, what did I say it was? I can't remember now. I have to go back up. 3 and 5, 4 and 6. So angles 3 and angle 5, and then angle 4 and angle 6. Okay. Next it says, go down. Which angles are not in the space between 1 and 2? Those are your exterior angles. So outside of the 2 lines, we're looking at this space here and this space here. So we're looking at angles 1, 2, 7, and 8. Those are your exterior angles. So let me write those down. Where am I? This one here. Angles 1, 2, 7, and 8. Those are your exterior. Now, out of those exterior angles, which ones are on opposite sides of the transversal? Those are alternate exterior angles. Let me scroll up. So 1 and then alternate exterior would be 7. 1 and 7 are alternate exterior. And then 2 and 8 are alternate exterior. All right, so 1 and 7, 2 and 8. Angles 1 and 7, and then angles 2 and 8. Okay. Now we're going to talk about corresponding. To find corresponding angles, okay, it says there are two non-adjacent angles on the same side of the transversal. One is an interior angle and the other is an exterior angle. All right, they're in corresponding locations. So let me go back up. So when I talk about corresponding angles, angle 1 is an exterior angle. So it's going to correspond with an interior angle that's not adjacent to it. So it can't be 4. All right. And it has to be on the same side of the transversal. So since angle 1 is to the right of the transversal and angle 5 is to the right of the transversal, all right, this is the interior angle, this is the exterior angle. They're on the same side of the transversal and they're not adjacent to each other. They're not next to each other. So 1 and 5 are corresponding angles. And then angle 4, oh, sorry guys, it's hard to make an arc, and angle 8 are corresponding angles. And then you have 2 pairs on the other side as well. Okay, but let me write down what I have so far. So 1 and 5, 4 and 8. So I have angles 1 and angles 5, and then angle 4 and angle 8. And then what are the other pairs? Well, the other pair would be 2 and 6, and then 3 and 7. 2 and 6, 3 and 7. Angles 2 and 6, and then angles 3 and 7. All right, then we're going to list vertical angles. Vertical angles are opposite V's, and vertical angles are always congruent to each other. So let me go up, I can mark them. So a pair of vertical angles would be like angle 1 and angle 3. They are opposite V's, all right? And then another pair of vertical angles would be angle 2 and angle 4. They are opposite V's. And then you're going to have 2 pairs down here as well. 7 and 5 are vertical, and 6 and 8. All right, so let me go down. All right, so we said angle 1 and angle 3 are vertical. Angle 2 and angle 6 are vertical. Angles, oh no, they're not. Not 2 and 6, sorry. Looking at the wrong thing. Try again. So my vertical angles are 1 and 3, 2 and 4, 5 and 7, and then 6 and 8. All right, the last thing we want to look for are the linear pairs. Everything that adds up to 180 degrees gives us a straight line, okay? So let me scroll back up. All right, so I'm looking at this straight line right here. And I see that if I add angle 2 and 3 together, that'll give me the straight line, or 1 and 4 together. All right, so 2 and 3 and then 1 and 4 are a linear pair. So let me go down. There's lots of linear pairs here. So we said angle 2 and angle 3. And then we said angle 1 and angle 4. Now, before I look down to the bottom portion of the diagram, let's look up, or let's look at a different line in that same spot. So we looked at this line, right, L3. Now let's look at L1. Which angles will add up to give me that yellow line? Well, if I add 1 and 2 together, right, that'll give me 180 degrees. And 3 and 4 will give me 180 degrees. So I have, I'm going to just list them here actually. Angle 2 and 1, and angle 3 and angle 4. Now we have to look down at this portion of the diagram. Here is a straight line. Which angles will add up to give me that straight line? 5 and 6, 7 and 8. So we have angles 5 and 6, and then we have angles 7 and 8. We have another line to look at though, right? If I look at line 3 and think about the angles that add up to give me that straight line, I have 6 and 7 are a linear pair. They're next to each other and add up to 180, and 5 and 8 are a linear pair. So I have angle 6 and angle 7 and angle 5 and angle 8. Okay, so those are your linear pairs. Ooh. I can get down there. There we go. All right, those are your linear pairs. All right. So guys, that is all we need to cover for today for the first lesson. I'll see you back here for the next lesson. Bye.